Hello guys, welcome back to our video, and remember we are still on our DCS simulator system. Right now in this video we are going to talk about SIS. So SIS stands for Safety Instrumented System. Now SIS is actually a process safety course, and it's one of the core elements of what we call layer of protection. SIS is a safety instrumented systems. Now what this means is that it's a system that uses instruments to safeguard our plants. Now how does it work? Now like I said, SIL is a very broad topic. Now I cannot explain everything about SIL in this video. I'm just gonna try to embed SIL into our DCS system so that we can see how it functions. But in order for me to show you how it functions, I will need to just explain a little bit about SIL so that you can understand. Now let's open our simulator. Alright, so this is our simulator. Now as you can see, this is a tank farm, and in the tank farm we have a lot of ESD devices. So we have ESD here, we have one here, we have one here, all of them trying to protect the tank. Now just looking at it, we feel okay, this is just a valve that opens and closes to allow flow in and out of the storage tank. But it goes beyond that. Okay, I'm going to show you how it functions. Right now I'm going to do this in two parts. In the part one of this video, I will demonstrate our loading activity from a crude truck down to the tank using a pump. So using this pump here, I will demonstrate it with this pump, and then I will show us if this is actually a SIS or not. All right, so we are going to be the judge, you are going to be the judge. So at the end of the day, we understand if the pumping activity from the crude to a pump to a storage tank is a safety instrumented system or not. All right, now like I said, this is a broad topic, so I'm just going to explain a little bit of it. Now let me just bring a board here, something like a board. So I'll just draw, let me just draw this here. So let this be a blackboard. Okay, so we are talking about SIS. So SIS. All right, so what is a SIS? Now a SIS is actually a combination of what you call a SIF. SIF. So if you have one, if we have two or three or more SIF, then we have a SIF. So a SIS is actually a system of equipments that are used to safeguard our plants. Okay, so that's a SIF. That's a SIS, sorry. Now what are SIF? Now before we go to SIF, let me bring it back to our operations. Now in the oil and gas or petrochemical plants, we have a lot of activities that are being conducted day in, day out. All right, now most of this activity results to what we call a catastrophic incident. Right now, how do we curtail these incidents? How do we reduce these catastrophic incidents in the refinery? That is where the SIS comes in. Okay, now what the SIS will do is actually to reduce the consequences and also the severity, right? Because if there is a protection, the activity, the event will take place, but there will be something that will be able to reduce the consequences, the danger of that event. Okay, and that is what the SIS is all about. Now the SIS is part of what we call layer of protection. In a plant, there are various layers of protection, okay, that are are built to protect the plants. One of them is the BPCS, which is the basic process control systems. So those are the basic control systems that actually protect the plants. Now we have other things like the pressure safety valves, right? The PSVs. Now all these devices, they work independently, and they are also called independent protection layers, IPL. So the SIS is one of them. We have operator response is also part of it. Alarm is part of it. We have emergency response plan or preparedness is also part of it. We have the dike. Now in a tank farm, we have a bond wall, a wall that actually protects when there is a spill, so that it doesn't spread to other part of the plant. That is also a layer of protection. Now today we are just explaining just one particular layer, which is the SIS, safety instrumented system. Now we are talking about SIF, which is the SIF. Now the SIF is actually the device that carry out the function, right? Now that device that carry out the function of protecting a particular equipment is what we term the SIF. So there are various criteria for an equipment to become a SIF. Okay, so one of them is the equipment must have what you call a sensor or an initiator. Okay, then it must have a logic solver, and it must also have final control elements, which is like a valve that closes and opens. Closes and opens, that's the control elements. The sensor is what senses what is going to happen, right? Okay, so it has to qualify, it has to have these three elements before it can qualify to be called a SIF. All right, so let me continue. Now that brings us to what we call SIL, which is safety integrity level. Safety integrity level, right? Now, this is very, very important. The integrity of the SIS is very, very important. Now we have 1, we have 2, we have 3, we have 4. So before an equipment can be termed a SIF, it has to fall into one of these categories. Okay, now what does the SIL actually do? Now the safety integrity level is, let's take for example human being, for example, right? We have integrity. I have integrity. If you call me today and you ask me, Mr. Nati, where are you? I will tell you exactly where I am. Currently I am sitting down recording this video. That is my integrity. Okay, now you can decide to actually rate my integrity based on levels, right? Level 1, level 2, level 3, level 4. Now what does level 1 actually means? Level 1 means that this particular device, the SIF, has a PFD, probability of failure on demand. Now what this means is that when we need a particular valve to function, right, is it going to fail us or not? So number 1 means it's going to fail us between 10 years to 100 years. So let's say a SIF is installed. Now after every 10 years to 100 years, that is when a SIL in level 1, a SIF in SIL level 1 will actually fail. Okay, now the higher the SIF, the higher the SIL, the better the SIF. Okay, level 2 means it will fail in 100 to 1000 years. So it means we can't even live to see that. 1000 years, who is going to live to see that? The plants will already be decommissioned by then. So that is what we need to see. Okay, so let's use another example to explain the SIL. Now let's take for example, I believe this example is for ladies. Okay, now you have four uncles, And I know ladies actually call their uncle mostly for money. Okay, so we are talking about financial integrity level, FIL. All right, now you call your uncle that you need money. Now whenever you call your uncle will always deliver, send you money. Okay, now but there is one of your uncle that in every 10 years your uncle is going to fail you once. So when you call that particular uncle, your uncle will tell you in 10 years, one of the time you call your uncle, he will say, I don't have money to send. Okay, so that is under level 1. Okay, so your uncle has failed you once in 100 years. That is SIL level 1. Now in SIL level 2, the second uncle, every day you call your uncle is going to deliver. Is going to deliver. Okay, now for the second uncle, you call your uncle in every 100 to 1000 years. That is when he's going to fail you once. That is when he's going to fail you once. So that means we are in SIL, or we are in FIL, financial integrity level, FIL level 2. Okay, so your uncle will fail you once in every 200 years. So between level 1 and level 2, which of the uncle is better? Definitely is level 2. Okay, now the higher the level, the more safeguard that particular equipment is going to be. Okay, now what makes the equipment or the safe to have the higher ranking is the architecture. The architecture. So during verification, during SIL verification, that is when you know the architecture of the SIL. Okay, in order to be placed in that particular area. Now this will also lead us to what we call SIL assessment, and SIL verification. So SIL verification is actually you trying to check if the SIL is actually doing the work, or if it's actually up to the level that it claimed to be. So you can do that by knowing the achieved SIL, and also by checking the architecture of the SIL. All right, so I don't know if you understand what is here. Like I said, I'm just going to show you a little bit. You can go through these terms and also try to read more. All right, so let's go into our software. And I'm going to take this one off. All right, so in this part of the video, let's assume we want to send in a crude from this truck down to 307 using the pump here. Okay, so first and first we need to impute the value. This is value. So currently we want to transfer 45,000 liters of crude to the tank, and we all know that these crude trucks are actually partitioned like this. So here is 15,000 liters, this 15,000 liters, this 15,000 liters. In total is 45,000. Now you can have some trucks that will have a fourth compartment, so this will not make it about 60,000 liters. Okay, but for this particular truck we are looking at 45,000 liters. All right, so in this example, what we want to actually look at is we are going to look at 3 scenarios. Okay, now in every scenario we are going to decide if this is a SIL or not. Okay, so in the first scenario, this is the hose that connects the truck down to the pump. Now here we have a valve here, a ball valve. We have a ball valve here, we have a ball valve here, and equally at the pump we have ball valves at the pump, and then we have what we call here we have what we call suction valve. So here we're going to have a suction valve, and then we're going to have a discharge valve. Okay, then at the suction we have a strainer and all the rest. Then at the discharge we have a check valve, we have a pressure gauge and stuff. So the first scenario is, let's say we've done our lineup. All the valves are lined up down to the pump, and then let's say the operators in the field put on the pump. All right, now when they put on the pump, let's say the pump is running. Okay, now all of a sudden an operator closes these 3 valves. Okay, what is going to happen? Now what will happen is that at some point there will be no crude on this pipeline, right, on this line. So if there is no crude on the line, it means it will get to a point where the suction of the pump will be dry, it will be empty. Now at that point, what is going to happen? What will happen is that the impellers of the pump will be rotating, they will be working, right, but there is no fluid, so it will be sucking air. It will either be sucking air, and then what we call cavitation is going to take place. Now continuous running of the impellers will do what? It will cause the seals inside the pump to get very hot. Now that is because the crude passing through the pump when it's working also serves as a coolant, okay, cooling the seal. All right, now with time it's going to damage the pump because the seal will get very hot, and at the end of the day it will get damaged. All right, so that is this first scenario. Now the question here is, we need to program what we call a trip on this pump. Now if we program a trip that can actually trip the pump off after some seconds when there is no flow, is this going to be a SIF or not? Can we categorize this as one of the SIS system, or can you categorize it as one of the SIF or not? So take a moment, think about it, and let's respond. Now like I said, is a SIF, which is a SIF is actually something that has these 3 elements: a sensor, a controller, and a final control element. Now pump is actually a final control element. Now if you introduce a sensor that can sense if there is a fluid or not, okay, and we have a solver that can actually look at the difference between the suction, and then try to look for a way to look at the time, and then shut the pump down, then does it become a SIF? Is this a SIF or not? So the answer is going to come later. Now second scenario, number 2. Second scenario is that okay, what if, for example, we have valves. Now everything is actually lined up, right? Everything is lined up, properly lined up, and then the pump is powered on. The pump is powered on. Now as you can see, the level is building up. Okay, so let's go to the second scenario now. Now in the second scenario, let's say the line is properly lined up to the pump, which is here. Now we want to transfer the crude down to 307 again. We start the operation, and then let's say all of a sudden our shutdown valve is tripped. Now what can actually cause the shutdown valve to trip off is when there is no supply of instrument air to the shutdown valve, or when there is no power. Now definitely if there is no power, it means the pump is also going to go off. But let's say the power is related to just the shutdown valve, and also there is no instrument air to the shutdown valve. Now there are 2 types of valves, control valves, or let's say this kind of valves. Now we have one that can that is fail to open, we have the one that is fail to close, we have the one that is fail last position, and also we have fail last position drift to close, fail last position drift to open. Okay, so let's say in this regard that this pump is actually fail close. Now if it is fail close means when there is no air, the valve is going to close. Now if the valve is closed, what happens? Now the pump is actually the impellers are rotating and we are pushing the crude forward through the discharge line, but then there is no flow because the shutdown valve is closed. Meanwhile, the suction is actually taking crude from the tank and is pressurizing the line. So what is going to happen is that the pressure on the line, on this discharge line here, from here down to the valve is going to start building up. The pressure will start going up, and when the pressure is going up, the temperature will also start going up, and you see that the pump will become very, very hot. The casing of the pump is going to be very hot because there is nothing going out, but the thing is rotating and pushing and taking more crude from the truck and still pushing and pushing. Okay, let's give an example. I'm in a room, or let's say we are in a room, about 100 people in a room, and the door is open, and now we have a mechanical wall that moves. Okay, now while the wall is moving and closing up in the room, the door is open so people can escape. Now after a while the door shuts, right? Now with that particular scenario, the wall is still closing up and then people are still trying to force the door open, right? So you notice that there will be pressure at the front close to the door. Anybody at the front will actually face an intense pressure, heat, temperature increase, everything is going to increase there, and all of a sudden the door will burst open, right? When the pressure of the people exceeds the design pressure of the door is going to burst open. All right, so that is exactly what's going to happen on this pipe. Now when the pressure is higher than the design pressure of the pipe is going to rupture. Okay, now we don't want that to happen. That is why we need what we call safety instrumented system. Okay, so we are going to program something that when the temperature rises or pressure gets to a particular temperature or pressure, is going to trip off the pump. So this scenario, is it a SIS? Is this a safe or not? Okay, give me an answer. Right, let's go to the third scenario now. Now the third scenario is this. Let's look at the tank. So currently we have about 16,400 liters of crude in this truck. Okay, now let's say the pump is on, and then let me put on the pump. So the pump is on, and then we have the crude going to the tank. Then we get to a point where there is nothing inside the tank. Okay, now the pump is still sucking, and at the point it will start sucking air. Now the container of the truck is actually not very thick, so what we call buckling can actually occur. To buckle in, right? That's because the pump is trying to suck the air inside the tank. So what we call buckling is going to occur. Now if we want to avoid what we call buckling, it means we need to include what we call a trip. So the trip, when the level gets to 0, when the level gets to 100 liters, we need a pump to trip. Okay, so in this instance, if the pump is working and tripping at this rate, is this called a safe? Is this a safe? Is this a seal? Okay, so let's see what happens. We are 2,400 liters. So when it gets to 100 liters, what it should do is what? Let's see. Okay, so my DCS is actually programmed to trip on a level of the tank gets to 100 liters. It can be 0, it can be 500, just to keep some margin depending on what you want. But here I made it 100 liters. Okay, so scenario number 3, is this a SIS? Is this a SIF or not? All right, so let's give the explanation now. So in the scenario number 1, what we mean is that the valves at the truck, we have a level on the truck, but then the valves on the line here are closed, and when they are closed, the pump is going to suck out the crude on this line, and at the point the crude on the line gets depleted, and so the pump is going to continue running with nothing inside. Now the continuous running of the pump is going to make the seal inside the pump to become very hot. Now continuously, when it continuously running, what will happen is that it will damage the seal and might even cause explosion. Okay, so in this case, what we are trying to safeguard is the pump. We are trying to safeguard the mechanical integrity of the pump. So this is what they call an asset protection. So an asset protection is not a SIS. It's not a SIS. Okay, this is an asset interlock. So it's an interlock that protects the pump from not getting damaged. So this is not a SIS. All right, so I hope you got it correctly. So the second scenario is if we have an inadvertent closure of a shutdown valve at the discharge of the line. So if there is a closure at the discharge of the line, what is going to happen? The line is going to get very hot, the pressure is going to go up, the pressure of the pump is also going to go up. Now the line is going to actually erupt, burst open if there is no trip to actually stop it. Now because the line, not the pump, is going to get damaged, that is a safe. We are preventing an eruption, because if there's an eruption on the line, definitely we have flow of crude on the atmosphere. Okay, in the environment, we have crude spill in the environment. So this is a SIS. Hope you got it correctly. So finally, the last one, scenario number 3, is buckling effect. Okay, now buckling effect is actually a SIS. So this scenario for the buckling effect is also a SIS. Okay, so hope you understand what you mean by SIS. All right, now this is not a process safety class, so even though I didn't explain the safety so much, you need to understand that this is not a process safety class. All right, so all we did was to demonstrate different scenarios that can be related to SIS using our DCS simulator. All right, so before you go, I have just one question for you, and in this question we'll look at the pump again. Let's go to the pump. So like I mentioned, there is a strainer at the suction of the pump. After the strainer, you can have it drain, then we'll get to the suction of the pump. Now what if the strainer is blocked? What if it is clogged? And then what if we include a pressure differential situation that can check the pressure of before the strainer and after the strainer, and then have a trip due to the pressure on both sides of the strainer? Is that going to be called a SIS, or let's say a safe situation? Okay, hope you understand the question, right? If we have a strainer and then we have a differential pressure that senses the upstream and the downstream of the strainer and sends the signal to the pump for a trip, is it going to be a SIS, or can the pump configuration be called a SIF? All right, so in part 2 of this video, I'm going to show you how to carry out the SIS of ESD systems, which is the emergency shutdown devices, and as you can see, we have a lot of them here. So in the next video, we're going to explain this thoroughly, and we're going to show you how this is going to work. All right, so see you in our next video.